Hi, welcome to this session on performing multi-machine virtual deployment using PowerShell. We will be running this prerequisite slide wherein we will be requiring some of the basic things that needs to be there before we get into the session. If you're not able to hear the audio, so you can check this configuration on here, which must say that join audio. You must be having your headset plugged in your computer. Please click on the voice and video from the live meeting menu and click join audio. Once your audio is okay, you should be able to see the speaker button enabled on the top left corner. Check if this is muted. Then please unmute if your PC speaker is working. And please do check if you do have installed the live meeting console on your PC. On the right hand side on the live meeting, you must see a feedback tab wherein you can enable or say that if you need any help, if you can't hear, or if it's slower, you can pass on the feedback to us as well. If you would like to ask a question between the session, so you can go to on QA session on the top and you can write up your question there in the ask field, and one of us will be responding to the answers you will be asking. We would recommend that you should watch this live meeting in the full screen. You can press F5 on your screens, and your minimum resolution required is 1024 by 768. You would also like to join some other VTC sessions we are having today. After this, we have some other sessions which you can join. I would like to introduce myself as well. My name is Amardeep Singh. I would be your moderator for this session and will be monitoring this throughout this session. If you have any help or you need any help, you can just speak on this session. I have Ravi with me, who is the speaker of this program, and I would like to introduce himself. Ravi works as a lead engineer with SharePoint Solution Engineering at Dell R&D Center, India. He's a technology blogger and writes regular at his site. He loves process automation and is a developer of several CodePlaks and other open source projects. He's also a regular speaker at BitPro user group meeting. I would like to hand over this session to Ravi right now. So, Ravi, if you can take up and start with the session. Thanks.
Sure. Thanks, Amardeep. Hey, everyone. A very good afternoon to you all. Can you all hear me? You can indicate that using the feedback buttons Amardeep suggested, right? So let's get started without any delay. So this session is about multi-machine virtual deployments using PowerShell. I'm not going to show you a specific framework that can be used to perform these deployments. Instead, I'm going to show you different approaches, and I'll tell you the pros and cons of each of those approaches and demonstrate one of the approaches that I'm using at the moment in my lab infrastructure setup, etc. Before we go ahead, my name is Ravikant, like Amardeep introduced. I'm a Windows PowerShell MVP. This is my 5th year as an MVP, and I'm a founder of PowerShell magazine. You have my Twitter handle on the screen. You can contact me at Ravikant, or just leave a message on my blog or PowerShellMagazine.com. I'll be more than happy to respond to you. All right, let's get started. So the way I've structured this session today is I have a sample deployment scenario. Let me first talk through that. So once you understand the sample deployment scenario, what I'll show you basically is different approaches that can be used to solve the problem at hand And then I'll take you through one of the approaches, which is using PowerShell workflows in my demo. And then we'll talk about, how exactly we should be approaching a problem like a multi-machine deployment, automation using PowerShell or any other scripting language for that matter. So the deployment scenario that I have today is, let's say, a SharePoint form infrastructure, right? A SharePoint form is a multi-tier form. You have multiple front ends, multiple application servers, and multiple database servers, let's say in a failover cluster or a mirroring kind of a configuration. So when you're configuring such a multi-machine, the multi-tier infrastructure using PowerShell or automating such a deployment, you need to consider various factors. For example, how many front-end VMs that you need, and how many application VMs you need, and how many database virtual machines. At that level, it is very, very easy. Deploying just the virtual machines and the operating system in that is not a very difficult task at all. But when it comes to the application deployment and the configuration, right, that is when you'll face some kind of a dependencies. For example, we cannot really configure a SharePoint form without having a database server already up and running. That basically means you need to have a SQL database service running before you can start SharePoint configuration wizard and start configuring a SharePoint form, right? So there are dependencies. So when you actually convert that into some kind of a workflow or some kind of a step-by-step approach, you'll have steps like create all the virtual machines, install operating system in the virtual machines, and then configure the network settings in each of the virtual machines, add them to the domains, and then install the application, the respective applications in each of the virtual machines. For example, in the front-end virtual machines and the application virtual machines of SharePoint, we will install SharePoint application, right? Either it's 2013 or 2010, whichever version that you have. And in the database VMs, we will install SQL Server, right? And also when I have multiple database servers, I may also want to configure either failover clustering or mirroring or always on kind of highly available technology there, so that I protect my database services as well as the data availability. So all these steps have to be kind of noted down in first place, and then you put the dependencies around that. For example, like I said, I want to complete my database mirroring configuration, and only after the database mirroring configuration is complete, I want to start the SharePoint configuration. I might have SharePoint installed on all of the front-end and application VMs, but I don't want to start the configuration until my SQL Server is ready. Otherwise, there's no point in starting the configuration also, right? Because you don't have the database server. By starting the configuration wizard, the first thing that the configuration wizard asks you is the database server name or the cluster name, etc. So you have to wait for database configuration to complete. So when there are such dependencies, right, the automation should be done in a proper workflow, right? So that is what we are really looking at in this deployment scenario, right? Like I said, the last point here basically says there are interdependencies during deployment. It's not just about SharePoint configuration wizard depending on the database installation. It could be much higher level also. For example, I don't want to start my database installation or trying to join these virtual machines to domain unless I have a proper network configuration completed on all of these virtual machines. So that is a prerequisite step. That's a dependency for starting either database installation or the SharePoint installation, right? So all these dependencies have to be tracked properly and should be monitored properly during the process of automation, right? So we can use multiple approaches there. Let's see, like I said, there are multiple ways to do this. And then you have the remoting and background jobs is one approach definitely, right? Remoting is not anything new to us. Using remoting, you can basically invoke remote commands. Commands are the remote systems from a single console. And of course, there are background jobs which can kind of emulate parallel processing. You can do multiple tasks in the background and create an impression that all of those tasks are running parallelly, right? And you can combine remoting and background jobs to achieve something what we just discussed. For example, I want to install, create multiple virtual machines. I can create a job, a background job for each of the virtual machine creation tasks. and run all of them parallelly in the background. And once that is done, I can start another job of, let's say, installing operating system, right? And once that is done, I can actually throttle how many background jobs I want to create, and then probably create a dependency using some other scripting methodology. For example, using remoting, I can actually find out whether a remote system has the SQL service running or not. I can find out those type of details, and then kickstart another background job or another script to perform, let's say, SharePoint configuration, right? But there's a lot of heavy lifting that you have to do, right? As a person who's automating the task, there is a lot of heavy lifting. You need to be careful about how you track the dependencies. Even, for example, if you miss a single dependency, the entire automation process or the task might be a failure, because if you don't track for exactly how much time the database installation is taking and how do you really handle the timeout values, etc. You can't let the database installation job happen forever. So you'll have to kind of put some timeout values, etc., and monitor for the timeout values, and then start the next task, etc., or fail the complete automation task itself. So all those dependencies and error handling has to be done by the person who's writing this entire automation framework now, or the automation tool itself, right? So that's a lot of heavy lifting. That's where you have things like workflows. Workflows definitely are based on PowerShell remoting, right? And they have the inherent features like parallelism and persistence. For example, right, you can do checkpoints. For example, at one point in the process, let's say there is a step that fails. When you restart the process, you don't want to restart the entire process from the beginning again, right? Using workflows, you can automatically create checkpoints within the automation sequence or the process, saying that checkpoint the entire automation process here, so that if there is an error and I restart the entire automation process, it has to resume from where it stopped or where it was suspended, right? So those type of features come automatically when you're using workflows, right? So you don't have to really worry about how do you start a remote session and start invoking commands, or you don't have to really worry about how do you checkpoint some of these sessions and resume from that, right? You don't have to put your own techniques to do all that. Workflows will take care of that for you. And also, if there is a task, for example, when I'm installing SQL Server, for some reason the setup.exe requires a restart of the machine to complete the SQL installation. So at that point in time, you can actually restart the job by suspending the workflow, and then the workflow will resume once you reboot the system, right? Resume from where it was suspended. So such features come automatically to workflows. Workflows are definitely, for example, other dependency tracking that I talked about, there are certain steps that have to be done in parallel. There are certain steps that have to be done in sequence. So all those constructs can be easily coded into a workflow. You have parallel activities, you have sequential activities in workflows, and all that can be easily grouped together into a single common workflow and used for your deployment purposes, right? But like any other approach that we are just talking about, workflows do have some limitations. Not all commandlets within SharePoint are really supported as workflow activities. That basically means you have to run those activities as inline scripts, right? So the moment you put something into an inline script, it loses the workflow nature. For example, I have a custom command that I wrote to, let's say, start my SharePoint form configuration wizard and complete it in an automated way. Of course, it's not a workflow activity. It's a custom script or a function I wrote. So I cannot run it as a part of a parallel activity or a sequential activity. Instead, I have to wrap that into an inline script, and that basically means I lose the persistence nature of the workflows. So we'll have to kind of work around that using other approaches. I'll show you some of the approaches in my demo. We'll have to kind of work around those limitations when using workflows. The next approach is, this is pretty much new in the space. You have desired state configuration. Desired state configuration is actually the configuration management feature in starting Windows Server 2012 R2, and you can also get the same feature set on down-level operating systems like 2008 R2 SP1 and Windows Server 2012 using WMF 4.0, that is Windows Management Framework 4.0. It also leverages PowerShell remoting and the SIM commandlets, the SIM-based, standards-based automation within Windows Server. So desired state configuration is more of declarative way of doing things, right? So at the first sight of it, it might look very simple, very clean, but remember that the DSC resources for doing all that behind the scenes have to be written by a person who's trying to automate the configuration tasks, right? So it is again as complex as either writing workflows or doing the dependency tracking and parallelism all by yourself using PowerShell remoting and background jobs. Right? I'll show you an example of desired state configuration also, but remember that DSC resources may not be available for all the automation tasks that you want to perform. So you have to write your own custom resources and plug them into the DSC framework so that you can declaratively use those resources in a automation task. Okay. I'll show you a couple of examples that are recently released by the PowerShell product team at Microsoft. They've released a bunch of custom DSC resources to, for example, deploy virtual machines, deploy domain controllers, etc., etc. So, one of the steps that I spoke about in the deployment scenario is about how we can kind of track dependency. For example, I want to wait for SQL Server service to be in a running state before I start my SharePoint configuration. So such scenarios, when you have to do that in a DSC resource, is extremely complex. So that is something that you have to handle yourself, right? For that, you have to kind of write a custom resource and ensure that you pass the proper parameters and what needs to be checked for exactly, right? Within the services or on the remote computer, and then use those DSC resources within your declarative configuration documents. So we'll see an example of that as well. Now, before I go into the demo, I just showed you different methods of doing, performing this kind of a deployment scenario. It's actually a choice. You can do it in any number of ways. Maybe you might find another way of doing it. I just explained only 3 ways of doing it, but you might find another way of doing it. Once again, every method has its pros and cons. So the way we choose the right approach is based on the environmental conditions with respect to how the entire infrastructure is deployed and designed. Based on those aspects, you kind of have to choose the right methodology. What mix of operating systems you have, what mix of PowerShell support that you have. Are you running PowerShell 2.0, 3.0, 4.0? Based on that, a lot of these design decisions or the choices will differ actually. All right. So with that, let me start with a demo. I'll show you walkthrough a workflow script that I had written. It is not really about the complete automation, end-to-end automation, including, let's say, database installation, SharePoint configuration, etc. I'll show you the approach and explain what I have done within that. And then, you can follow a similar approach and then extend the script that I have to add the remaining pieces like installing applications or checking for services, etc. So let's start with this demo. The first thing is do you all see my screen? I hope that's a yes. Let's get started. All right, so the first thing that you need is basically some type of a configuration data. For example, when I have to configure or create multiple virtual machines, each virtual machine has its own characteristics, right? For example, my SQL database servers have higher CPU configuration and memory configuration than my SharePoint front-end or application virtual machines. And also each of those virtual machines have their own IP configuration. Each network adapter that you connect to one of these virtual machines has its own VLAN configuration, right? And also, what type of operating system that you want to run, how it should be installed, etc. All those are configurable parameters, right? And also when I'm deploying, for example, in a virtual infrastructure like what I have multiple Hyper-V servers. They're not clustered Hyper-V servers, but they're standalone member servers in a Active Directory domain. So when I'm actually deploying virtual machines in such a scenario, I want to deploy virtual machines on different hosts. For example, I don't want my both database virtual machines, which are in a kind of a mirror configuration, on the same physical host. That's for obvious reasons, because the host goes down, my entire database is gone, right? So for that reason, let's say I want to specify multiple physical hosts for each of the virtual machines. So these are some of the configuration parameters that you have to think through before you start automating your entire deployment process. So in my case, I'm actually using a hash table here, right? Let me walk through this one by one. So this is a simple hash table I created. I'm just creating two virtual machines for this demo. So what I really have is a hash table of hash tables, right? As you see, these are kind of nested in nature. So this is the top level hash table I have. And inside that I have VM1, which is another hash table, where I'm taking different parameters like what is the physical host name, and what should be the name of my virtual machine, what should be the processor count, what should be the memory size of these virtual machines. And I'm not really installing operating system here because that's a waste of time, right? I can have a VHD already pre-populated with the OS bits and then attach it to my virtual machine and then boot from that automatically. I can do the post OS configuration in the new virtual machine that I have. So I have a template VHD which I'm using, and I'm just giving a name to this OS VHD here. And of course, I need some network parameters also. How many network adapters I want to connect to this virtual machine. So in this case, for this particular virtual machine, I have 3 network adapters getting connected. And what is the name of the network adapter? Let's say management, to which virtual switch it is connecting, VM_internal, and I also have IP settings. For this management adapter, this is the IP address I want to assign. Right? This is my IP address, this is my subnet, this is my default gateway, etc. Why am I using an array here? Although I've specified only single IP address here, we will talk about that a bit later. So, but this is how I've basically designed my configuration data, right? The same thing will be applicable for the second VM also. I have similar details for my second VM also given here. Right? If you look through the IP settings, again, it has a different IP, probably in the same IP range, and it has a VLAN ID specified also, right? So let me just make sure I don't have these virtual machines running. Let me delete them first if they're running. Yes. Let's delete these two, and I probably have to delete the virtual hard disk as well, which we just created. All right, so we have a clean server now. There are no virtual machines running, there are no hard drives created, etc. Let's look at the workflow script that I created. So deploy-VM is the workflow I created, and I'm passing the configuration data we just talked about as a argument here to that workflow. Now let's look at the workflow itself. Since I'm using a hash table kind of a thing, within which I have multiple other hash tables for each virtual machine I want to create, I'm taking that into the for each parallel construct here. So what happens is each of those virtual machines as a single object, for example, over here in the configuration data, I have VM1 and VM2 as two different VMs that I have to create, right? So when I come to this particular script block within the workflow, what happens is it actually goes through each and every hash table within the master hash table and runs the entire script shown within these for each block at once, right? For example, all of these things are run parallelly, right? I said for each hyphen parallel, for each key in the hash table, get the VM configuration data. So the VM configuration data will have the internal VM hash table. For example, in this case, VM1 in the first iteration, right? And all these things are happening parallelly. And then this is where I have a inline script, okay? Using the inline script, what I'm basically trying to do is the first code here, this segment or this script block, I'm just trying to copy the template VHD file as a VHD file, otherwise a virtual hard disk file for the multiple virtual machines that I'm creating, right? So what essentially we're doing is cloning VHDX files for OS VHDX, okay? So this is what we are trying to do. We're getting the host path where exactly the virtual machine hard drives are stored. We are then joining the path here with whatever OS VHD file name that we mentioned in the configuration data, and we are copying the item, okay? Now, how does it know where to run the command? That's where we are basically saying use -ps computer name as a argument, a parameter, and pass the server name which is mentioned in the VM configuration as host, right? So that's what you see here. I'm passing that value as a argument to the -ps computer name parameter. So once I do this, what really happens is it will go and copy all the parallelly on all the systems for each and every VM configuration I have in the configuration data. It will just take the template VHD and make a copy of it in the respective locations, so that once that is done, when we create the virtual machine, we just attach to that virtual hard drive, okay? Once that process is complete, we have to create a virtual machine. So that's what I'm doing here. So I have the same process again. I'm going through the same key functionality here. I have multiple parallel constructs here. This is one which I'm doing it parallelly, and then once I come out of that, I'm running another parallel construct here, so that multiple tasks can be run simultaneously on different systems here now, right? So we do the same methodology here also. We already copied the hard drive. I'm just getting that path into $OS VHD path variable, and once I have that, I create a new virtual machine using the configuration data that we just derived from the hash table. The dollar using scope operator is required here because the variables that are defined in the global scope of our workflow are not available inside an inline script, right? So that's when we have to use dollar using, that is the scope operator for us now. So it basically gets the global variable into the inline script scope as well, right? So that's why I'm able to derive all these values from the configuration data that we just captured. So I'm creating a virtual machine after that, as you see here. And if you see VHD path, we are just connecting whatever VHD we copied in step 1, right, using the other inline script, and we are creating the virtual machine, okay? Now, once the virtual machine is created, we kind of change the processor count, because while creating a virtual machine, there's no way of specifying how many processors we want, right? So instead of that, we create the virtual machine, then go to the set VM commandlet within the Hyper-V module, and then change the processor count to whatever we have specified in the configuration data. Once we are done with that as well, we just come here and remove any existing network adapters. That is because whenever you create a virtual machine it automatically adds a network adapter to the configuration. So in this case, we don't really need that existing network adapter, because we want to create our own network adapter with a specific name assigned to it, right? If Hyper-V creates a network adapter for me and attaches it to a virtual machine, by default it will be just listed as network adapter. but instead of that, I want to be able to identify VNIC assigned to your virtual machine with a specific name that I provided in the configuration data. Okay, so that's what we do here. So in the configuration data, you basically have seen multiple network adapters defined inside the configuration data as a part of that, right? I have multiple VLANs also assigned to all of them. So within this for each, this is not a parallel construct. And by the way, remember, whenever you are working with the VM configuration, for example, you're changing the VM configuration of a single VM object, you cannot do multiple configuration changes at the same time. Okay, it won't necessarily allow you to do all that. So what you have to do is you have to do all those changes in a sequence. You have to wait for the first update to the VM object complete and then go for the rest of the VM object updates.
I would urge all the attendees to please put yourself on mute because we are hearing a lot of background noises there, so it might be disturbing the session as well.
All right, so here is a question. Let's take this before we go ahead with the demo. Deepak is asking, where do we specify the Hyper-V host where the new VM are being created? So Deepak, like I mentioned, within this inline script basically takes the workflow common parameters, and one of the workflow common parameter is -ps computer name. So in this case, in the configuration data, I have specified that, let's say I want the first VM on server -1. So I specified that as a parameter here. So this is the beauty of workflows, right? All these commands, I'm not really using the -computer name parameter that the Hyper-V module provides. Instead, I'm delegating that job to a workflow activity, which is inline script activity, and saying that take this bunch of commands that I have over here and run them on this host, right? So by saying so, it is actually going and creating virtual machine on a specific host, which is defined in the configuration data. Okay. I hope that answers your question. So coming back to the script. So what I have here is I'm gathering the adapter name, switch name, and VLAN ID that I require for my network configuration. Then adding a VM network adapter to the VM we just created, right? With whatever name that we specify in the configuration data, and attach it to a switch. So one thing that you would notice is we are not creating a virtual switch as such. We're assuming that the switch already exists in the infrastructure and we are just connecting to that. And once the VM network adapter is created and connected to the virtual machine, we kind of set the VLAN ID on that network adapter. Okay. So we add it in the access mode. We just add the VLAN ID to the network adapter that we created. So in the first process, we kind of cloned all the VHDX files, a template VHDX file for the use with the other virtual machines that we create. And in the second process, we created the virtual machine itself, changed some of its properties like assigning multiple processors and removing the existing network adapters and adding new network adapters as specified in the configuration data. Okay. And the third process is where we kind of start the virtual machine and then ensure the virtual machine IP addresses are assigned. Okay. So again, we are not using any of the operating system because we don't have network connectivity to the operating system yet, the guest operating system. So everything has to be done from the host, and that's what exactly even this activity does here. So what it basically does is, again, using another inline script, we are starting the virtual machine. Since we are attaching a virtual hard drive with pre-installed OS in it, it has my integration components already installed in it. So when I start the virtual machine, the integration services components will also start automatically, and that's what I'm checking here. So I'm checking until the heartbeat status is set to OK, applications healthy. You can actually use a different enumeration also here, but I'm just checking for the string that the enumeration provides me. So I'm checking for that. I'm waiting until the heartbeat status of the guest operating system changes to OK state, right, or the healthy state. Okay. So after that is done, I have a function defined here. I'll show you that function in a little bit. I have a function defined within the inline activity. Okay. Using that function, I'm setting the network configuration for each of the adapters. Okay. And once again, let me reiterate this point. I'm not doing anything inside the guest operating system yet. All this is happening from the host. I'm actually injecting IP addresses into the guest operating system using the Hyper-V integration components. Okay. So the function that we are using here is basically let me remove this piece of, So it's actually using the WMI namespaces in Server 2012 R2. So using the WMI namespaces, we can actually inject IP address into the guest operating system. But we need to make sure we can inject it even when the VM is offline, but that won't give you a consistent experience. Sometimes some of the IP addresses will get assigned and some of them won't get assigned to the guest virtual NICs. So as an error handling point, what I'm trying to do here is I'm waiting for the heartbeat component to say that the integration services inside the virtual machines are healthy and running. Only after that, I'm actually running the set VM network configuration. So this function I'll be posting again. I mean, I have this on my blog already, but I'll share this workflow script also with you guys, so you can kind of look through the code and understand what exactly we are doing there. So again, like any other inline script that we used to achieve parallelism, we are using the -ps computer name parameter, right? So within the for each -parallel construct, what we are basically saying is run this inline script parallelly on the computer name specified using the -ps computer name parameter. Okay. So within this workflow that I'm demonstrating here, we are not actually doing any application deployment as such, or even joining the domain, etc. But with the approach that I just showed you, right, waiting for the virtual machine integration services to come up, etc., you can actually achieve the same thing for joining the domains. And right now, once you have the network connectivity to the guest operating system, of course, you can do everything over just a plain simple PowerShell remoting, or again, pass it through the same workflow inline script activities, right? So let's try to run this workflow and see. We have everything running. We can see the output. So the first inline activities started is actually running on both the servers that we specified. It is making a copy of the template VHD. It's I think around 10 to 12 gigs, so it might take a while it clones the VHDX file for operating system VHD. So once this activity is done, we kind of go and create all the virtual machines. Let's see. So it's copied all the VHDs. I think it's still copying. That's why it is not in the second activity. You can see the VHD copied already to the whatever designated locations that we have. It might be still writing to that location, so just give it some time. Oh, it's actually taking longer than I thought. Interesting. This is how most of the demos are. I think, when I'm actually doing all the just rehearsing all the demos, etc. By this time, I've actually got all the virtual machines created. But right now, it is taking longer just to copy the files. Okay, you can see that it started creating the virtual machines. It added all the network adapters, and it is starting the virtual machines. And it's now waiting for the virtual machines to come to a integration component OK status.
Ravi, there is a question posted by Hemant.
Yeah. So how do we add checkpoints? You can. So right now I'm using a inline script. Using an inline script, I cannot really check the. do a checkpoint within an inline script, right? So I have to do it outside of it. So after every, for example, I have the, let me come back to that. So right now we have the virtual machines created, and this success output that you are seeing is actually coming from the set VM network configuration commandlet, the function that I wrote. So it is basically saying that all the IP configuration settings have also been pushed to the guest operating system. Let's just verify that. So this is created, it's running. And if I go to the networking tab here, I should see the IP addresses I configured, right? Now the IP addresses are assigned to my virtual machines. Again, the same thing I check here. It is also assigned. So let's connect to one of the virtual machines just to ensure that inside the guest operating system also we see the same IP settings, etc. Okay, so this is what I talked about. Even this can be automated used by pushing unattended XML file into the guest operating system, which are not automated, but it's not a very difficult task because with Server 2012 R2 you have the copy VM file commandlet. So using that you can actually push a file into that, just reboot the server, reboot the guest operating system. It automatically picks up the unattended XML from the root location on the VHD and then automatically starts configuring this entire OB process for you, the out-of-the-box experience process for you. So we'll just verify the IP addresses, etc., and then get back to our discussion on the checkpoints. So we have 3 network connections, and we have already pre-configured everything. Right, you see the IP addresses, everything assigned here, 192.168.172 series IP, and you can see that the local server will have the IP addresses, everything set to static mode. Right, by default, everything is DHCP in Windows operating system when you initially configure install operating system. So, but since we already injected the configuration into the guest OS, we should have static IPs assigned to all of it. Okay, so properties, yeah, so there we have. We can actually push the DNS server IP addresses also. I don't have that in my configuration data, but that can be done as well very easily. Using the same script, actually, I have the functionality within the set VM network configuration commandlet. I just did not use that in my configuration data. Alright, so now coming back to the question on checkpointing. So within an inline script, we cannot really do checkpoint. Inline script does not support that. but for each parallel construct support, and within workflow you can use it anywhere. For example, over here I can just do a checkpoint. Checkpoint workflow here, right? So whatever activity has been done so far, if you restart the after this point, let's say you suspend the workflow over here, and then you say when you restart the entire workflow, you can just use resume workflow command line and say deploy VM with so and so configuration data. It will actually resume from this point onwards. Okay, since you suspended here, it will start at the very next location. It will resume the workflow from there. So you basically have to place checkpoint at different places like this. Okay, the inline script also supports. There is a -ps persist. So this is the switch parameter. You basically say that by putting -ps persist on the inline script, you're saying that whenever there is a checkpoint that happens, you just persist the state of my inline script. I mean, not really the inline script, but whatever happened until then. So you can actually do that as well. But you cannot use checkpoint workflow or checkpointing inside an inline script. Okay, that's not possible. All right, so this is one of the scripts that I'm using here to perform these multi-machine deployments in my lab setup, etc. Right? I can extend this immediately. Like for example, I can put change the configuration. So I can just add one more VM node. That's basically another hash table here. Just add it as VM3, and the same workflow should be able to create a third virtual machine parallelly, right? So that's how I've been doing it using workflows. Like I said, there is desired state configuration way of doing it also. Microsoft recently released. Let me go back to that. Let me show you that first. So Microsoft recently released this Hyper-V DSA resource, right? That's what you see in my screen sharing right now. So using this DSA resource also, you can create virtual machines. Of course, you can create virtual hard drives, you can create virtual switches, and then attach network cards to your virtual machines, etc. Attach those virtual hard drives you create with the virtual machines, etc. All that can be done using this resource module. I'll show you an example of that. So this is directly from the same page which I just showed you, right? So within DSA, you have different terminology. This is a configuration keyword, which is essentially a function which takes different parameters and resource definitions, basically. So within the configuration, I have a virtual switch resource defined here. All we are basically saying is there is a VM switch, X VM switch, DSC resource available. So using that, create a virtual switch with these parameters. The name of the switch should be test switch. Ensure equals to present basically says if it is already existing, don't do anything. If it doesn't exist, go create that virtual switch. And the type should be set to internal. Okay. Similarly, we create a VHD also. And like I said, you can copy XML files. So they have created a VHD file resource which can be basically used to copy files into the virtual hard drive after it is created. And then finally, a Hyper-V virtual machine creation itself here. Okay. So using this resource, what they're specifying is the name of the virtual machine should be this. The switch name to which it will connect should be test-switch. This is actually the switch that we are creating in the first step. Rest all details like processor count, max memory, min memory, restart if needed, yes, whatever. Depends on is the key here, right? Now what this attribute basically says is before you start creating a virtual machine, ensure that this VHD exists, this switch exists, and this particular file is copied into the VHD that we created. Okay. So once all these things are done, they go create a virtual machine and put it in the running state. So at the surface of this whole thing looks very simple because of the declarative syntax. Everything looks very clean compared to my workflow script here. My workflow script, I think, you know, if you are not really paying attention to the details, you can actually miss a lot of functionality that I have coded here, right? But the configuration document that Microsoft published, or the PowerShell team published here using the X-Hyper-V DSC resource, is very clean and simple. Looks simple at least. But remember the fact that there is a DSC resource which is created that is doing the entire job. For example, you can go to the, for example, in my case, I've copied it in users, Windows PowerShell modules. These are the DSC resources, right? Now, if you go to the Hyper-V resource, whatever I have kind of coded in my workflow is all being done by the function that is here. Okay. So there is actually the same kind of a functionality which is implemented as a DSC resource. Okay. Sometimes, like I said, checking for dependencies, waiting for a service on the remote system to come online. Those activities, doing that, those kind of activities in a DSC resource can be quite complex. Okay. And especially when, let's say, some service on node 1 depends on service on node 2 to come up. There's no inter-node dependency that you can create within DSC as of today. Okay, there's only within the node you can between multiple resources. What you see here, all of these resources that you see, the switch, VHD file, and the Hyper-V VM, etc. Those are the resource configurations defined on the same node. They're not defined on the separate nodes. So within the same node, you can define all the dependencies using the parameter depends on, like this. But when you are doing multi-machine deployment where you are involving multiple servers, you have already seen in my case where I have one virtual machine getting created on server 1, one virtual machine getting created on server 2, etc. The inter-node dependency cannot be tracked easily, and creating a DSC resource for that is very complex. Okay, so I'm not going to execute this configuration document, but I just wanted to show you how exactly it looks and what are some of the semantics of a DSC configuration document. Okay. Again, it's a choice. Like I said, it depends on various other factors, like what operating system you're running, because DSC is not supported anywhere below 2008 R2, right? But using PowerShell remoting, you can go up to the down level operating systems like Windows XP. Workflows also require PowerShell 3.0. I think workflows also can run on Server 2008 SP1, I think. So the operating system and the software matrix is sometimes governs what kind of scripting approach or the framework that you can leverage when automating your processes. So that's all I had. Let's take a few more questions. I see a few more here. Deepak is asking, so when I use checkpoints, where will the metadata store which resume the workflow next time? Which machine location? So the checkpoint, wherever you specify the -ps computer name, the checkpoint information is stored on that system. I think it is in the app data of that particular user who is running that workflow. But when you're, when you're resuming that, you either have to manually resume the workflow, or you have to use a scheduled task. So once the computer restarts, once it logs on, you start the workflow immediately again using the scheduled tasks. So that process has to be done yourself. There's no automatic resume of workflows on a computer reboot.
Ravi, since we don't have much of the questions, I would just like to thank you for your valuable time and for delivering this useful topic. I hope the audience have enjoyed and the session was equally useful to them. I would like to mention that here we we are seeking a feedback, and which is quite very important to us for all the sessions we are planning. And I request all the feedback attendees to submit their feedback. The event team will be sending a survey to them. Please do fill in the surveys because we value your feedback. Thank you, and looking forward to see you in the next events we have. And I would like to thank Ravikant once again to you as well.
Thank you, Amardeep, and thank you all the folks who joined us today. I hope this session was useful. You found it useful. So any questions, you can reach me on Facebook. Many of you are there on my Facebook and the PowerShell Bangalore user group. Just drop a question there, or the Twitter account I just mentioned in the beginning of the session. So we'll be happy to take those questions. Thank you.
Thank you all.